Okay, everyone. So we are here at the final part of this lesson. So all about higher order equations. Now, in the previous section, we discussed about second order equations, right? And the different cases and different possible cases. So the only difference here is that for higher order equations, we will be um, finding the roots of nth degree polynomial equations. Okay, so in the previous section we only solved a quadratic equation. So here, if we have a third order equation, then you will need to find the roots of a third degree polynomial equation. Okay, and the cases that we learned in the previous section will still be applicable here. So how are we going to apply those? So let's do some examples to make this a lot clearer. Okay, so let's start with the first one. So we know that the auxiliary equation for this is what? M cubed plus 4m squared minus 7m minus 10 is equal to 0. Now we are not going to discuss the how to factor a polynomial equations here. So for these examples, I'm just going to give you the factors directly. And then the important thing that we need to learn here is how to format our general solutions based on the cases that we learned in previous videos. Okay, so the factors here, if you factor it out and apply the zero product property, you will get these following m values. M1 is equal to -1, M2 is equal to 2, and M3 is equal to 5. Now, as you can see here, these are three distinct roots. Now, this is case 1, right? So how are we going to format the general solution for this? Okay, so that is simply y is equal to C1 e raised to, so -1, x, so negative x or -1. Let's just write negative x here. So negative x. And then plus C2 e raised to 2x, and then plus C3 e raised to 5x. Okay, so this is the general solution for this particular equation. Okay, so these are three distinct roots. So if you have another distinct root here, let's say if you have m4 is equal to 6, then you can just add here. Okay, so the same format. Okay, let's now do another example. We have here a third order differential equation. So let's write the auxiliary equation for this. This will be m cubed plus 3m squared minus 4. Okay, is equal to 0. Okay, so if we factor this out, we will get m minus 1 squared multiplied by, m minus 1 multiplied by m plus 2 squared is equal to 0. Okay, so we have m1. Now the factors here are the m values here. M1 is equal to 1, m2 is equal to -2, and m3 is equal to -2 as well. Okay, so let's write this down here to make it more clear. So m1 is equal to 1, m2 is equal to -2, and m3 is equal to -2 as well. Okay, so as you can see here, we have one distinct root. And we have this. We have -2, which is a repeated root. So how are we going to structure our general solution here? So what we're going to do is we're going to apply the case 2 for M2 and M3 and case 1 for M1. Okay, so let's write it down. Let's use different colors here to make it a lot clearer. So let's say y is equal to, so for case 1, let's use yellow. So we have here C1 e raised to x, right? And then we add. Now what is this? So this is the repeated root. So what we're going to do, so this, since this is M2 is the first one, we will add here C2 times e raised to -2x. Now what are we going to do with the repeated root? We multiply this first one by x, right? So plus C3 x e raised to -2x. Okay, so that is this is our general solution for this particular equation. Okay. Okay, so let's go to the third one. Okay, so we have a third example right here, and this is a fifth order. Okay, so fifth order differential equation. Okay, so if we get the auxiliary equation for this, we get m cubed, m raised to 5 plus 5y raised to 4 plus, so 10, oh, why did I write y? This should be m. So m, and then 10m cubed plus 10m squared, and then plus 5m plus 1 is equal to 0. Okay, so if we factor this out, actually we're going to get m plus 5, m plus 1, m plus 1 raised to 5 is equal to 0. So what this means is that we have m is equal to negative 1, and then this is repeated 5 times. Okay, so this is like case 2, but we have 5 repetitions here. So how are we going to do this? Okay, so the shortcut here actually is you just keep multiplying by x. So if you notice here in the previous example here, here is the first solution, right? E raised to c2 is e raised to negative 2x. And then we multiplied x for the second one, so for the repeated root. Okay? So here, we repeated it 5 times. So we keep on multiplying x until we get 5 solutions. Okay, so how are we? So let's do exactly that. So C1 is equal to e raised to negative x, right? So since this is negative 1x, then plus, so this is the second repetition. So C2x e raised to negative x. Then for the third one, we multiply x again to this previous one. Okay, so we will get x squared e raised to negative x. And then for fourth one, you will get x cubed e raised to negative x. And for the last one, c5 multiplied x squared e raised to negative x. So this is our general solution. Okay, so that's it. That is the shortcut for our repeated roots. Okay, and now we have here another fifth root. We have here another fifth degree, a fifth order. So the words are getting jumbled here. So I'm sorry for that. So let's write the auxiliary equation. We have here m raised to 5 minus 3m raised to 4 plus 3m cubed minus m squared is equal to 0. Now this is another interesting case. So if we factor this out, we get m squared multiplied by m minus 1 cubed is equal to 0. So what this means is that we have these following roots. No? M is equal to 0, and this is repeated 2 times. And then m is equal to 1, and this is repeated 3 times. Okay. So let's color code this so that you won't get confused. Okay, so basically another case of case 2. So let's write down our solution here. So y is equal to, so we have here 0 repeated 2 times. So let's get the first one for that. Right? Let's just get the fundamental set of solutions here, not the general solution first. Okay, so for this one, for this m is equal to 0, we know that the format is y is equal to e raised to 0x, right? 0x, so we will get 1, right, for the first one. Okay, so we will get 1. And then we know that for the second one, you will get y is equal to x e raised to 0x. So this is 1, so we will get x. This is 1, so you will get x, right? So that is it for this m is equal to 0 here because it is repeated 2 times. Now how about this m is equal to 1 repeated 3 times? So we will start over again. So y is equal to e raised to 1x or x, right? And then the second one, for the second repetition, we will get e raised to negative, x e raised to x. And then for the third one, we will get x squared e raised to x. Okay, so those are the solutions. We write that in our fundamental set. E raised to x, e raised to x, and then x squared e raised to x. Okay, so there you have it. Now we can write our general solution. Okay, so if we write our general solution, y is equal to c1 plus c2x plus, you have here c3 e raised to x, and then plus x e as, I forgot the c. So we have here c4 x e raised to x, and then plus c5 x squared e raised to x. Okay, so this is it. Huh? So we have it right here. So this is our general solution. Okay, so let's go to our last example. So this will involve a complex conjugate complex roots. Okay, so if we write down the auxiliary equation for this, we have m raised to 4 plus 2 m squared plus, this is 1 is equal to 0. Okay, so if we factor this out, we will get m squared plus 1 squared is equal to 0. Now, if we apply the zero product property here, so we will get m squared plus 1 is equal to 0, and m squared plus 1 is equal to 0. You will get m squared is equal to -1. So m is equal to plus minus I. And the same goes for this second one. So m is equal to plus minus I. Right? Okay, so let us now recall the format for the complex root. So we have here m is equal to alpha plus minus I beta. Okay, so if we take a look at this first m right here, this is the same as saying m is equal to 0 plus minus I. So our alpha here is equal to 0 and our beta is equal to 1. Now let us substitute this to the general solution of case 3. So we will get y is equal to c1 e raised to 0x, right? Because alpha is 0. And then multiplied by cosine beta x. So since our beta here is 1, we get cosine x. And then plus c2 e raised to 0x again, plus sine sine x. Okay, so if we simplify this, we get c1 cosine x plus c2 sine x. Okay, because e raised to 0x is equal to 1. Okay, now these are our solutions, right? C cosine x and sine x. And then we basically repeat them. So these are complex and they are repeated. Okay? So this is also a case of case 2. Another case of case 2. So we're just going to add the repeated roots. So the format for that again is we just multiply it by x. So we get C3. So for the positive I, we get x cosine x, and then for the sine we get c4x sine of x. Okay, so that is our general solution, which is really cool. Okay, so that's it for this video. I hope you learned something in this lesson. And yeah, so we need to do a lot of reviewing for factoring polynomial equations. And that's basically it. So thank you for watching and see you in the next lessons.